Hi class, and welcome to our lesson on wave behavior. In this particular video lesson, we're going to look a lot at the phenomena behind waves and some of their different behaviors that occur. Some of the behaviors that we're going to explore in this lesson are reflection, refraction, diffraction, and interference. First, let's talk about reflection because this is the one that is most common to us. We all know I look in the mirror and I see a reflection of myself. But have you ever thought about scientifically how that happens? Well, reflection occurs whenever a wave will strike an object or surface and it bounces off. Light waves, whenever light waves are reflected, they're produced by some type of light source. So whether it's the sunlight or the light bulb in a room, it's some type of light source in order for light waves to be reflected. They'll bounce off your face, they strike the mirror, and then they reflect back to your eyes. So that's how we're able to see a reflection of ourselves in a mirror. Well, how are you able to see just the different objects around you from day to day? That's because light waves are striking those surfaces of those objects and bouncing back into your eyes. So reflection of light enables us to be able to see the various things around us. Sound waves can also be reflected. This is what we will call an echo, and that's just basically where sound waves will strike a surface and they bounce back to your ears. Here are a few pictures that kind of illustrate the wave behavior of reflection. Just make sure that you draw at least one of these on your graphic organizer. Now let's look at refraction. Refraction involves the bending of waves as they move from one medium into another medium. Remember last week we talked about that waves can travel through mediums. Mechanical waves actually have to have a medium in order to move around and transfer energy. Electromagnetic waves, such as light, can travel with or without a medium. So whenever these waves are moving through different mediums, moving from one medium into another, their speed is going to change, and that's what causes refraction to occur. And when refraction occurs, it makes things look as it makes things seem as what they really aren't. So if something may look a certain way, but actually because the waves are refracted, it really doesn't look that way. And we're going to look at a picture in just a moment to kind of clarify that. Light waves and sound waves, of course, can both refract. Whenever light waves are passing from air into water, they're going to slow down and bend. And we are going to have a separate lesson where we talk about the speed of waves as they travel through different mediums. Electromagnetic waves are going to tend to travel much faster in less dense states of matter, okay, where the particles are not so close together, they're more spread out. So that's why when it goes from air into water, so you're going from air where the particles are less dense into water where they're going to be a little bit more dense and close together, those waves are going to slow down and bend. Sound waves are kind of the opposite of that. They're mechanical. Mechanical waves are going to tend to travel much faster in particles that are more dense. So if sound is traveling from air into water, they're going to speed up. Sound waves will also bend as they move through air of different temperatures. So basically, refraction has a lot to do with the bending of waves as they move from one medium into another. And either those waves are going to speed up or they're going to slow down, depending on the type of wave that it is. Let's look at some pictures to kind of clear up what refraction would look like. Now, this is an example of what that wave is doing as it's moving from one medium into another. So this light ray is going from air into water, so it's going to bend, okay? And remember we said that as it moves from air into water, it slows down, and that's what causes it to bend, is the slowing down of that wave. This would be an example of something that we might see. It appears to be broken, but this pencil in this glass really isn't broken. What's happening is when you look at it right here at the surface, this is the light wave traveling from air down into water. Well, that light is going to bend because it's traveling into different mediums. So this pencil in this cup is going to appear to be broken, and that is what we would call a picture of refraction. Okay? Now, let's talk about diffraction. It's easy sometimes to get refraction and diffraction mixed up because they both involve the bending of a wave. However, diffraction is the bending of waves when they're moving around a barrier. Remember last week when we were talking about a teacher is sitting at her desk with the door closed, but she could still hear sounds in the hallway. And we talked about how the sound waves were kind of moving around the door, moving around the wall. That is because of what we call diffraction. That's the bending of those waves around a barrier. So that's actually what's happening whenever a teacher is sitting at her desk with the door closed, but she can still hear students in the hallway. The amount a wave diffracts is going to depend, of course, on its wavelength and the size of the barrier or the opening. Light waves, we've looked at light waves on the electromagnetic spectrum. That's the same thing as visible light. Their wavelengths are pretty small. They don't have a very large wavelength. So therefore, light waves are not going to diffract around large optical obstacles, as much as sound waves can. That's why I'm going to hear the students coming before I actually see them, because the light waves are not diffracting as much as the sound waves are. Here are some examples of the diffraction of sound waves. This is just a basic example of what happens. This red bar represents your barrier, and as the waves go through, they bend. A real life example of diffraction, of course, would be light diffracting around clouds. It can bend around those clouds. And then this is an example of, here's a radio and here's a boy on the other side of this wall, but the waves are bending and diffracting around the wall so the boy can still hear the radio, even though he can't really see it. Our last type of wave behavior is interference. Interference occurs when two waves combine and form a new wave when they overlap. Um, Whenever this overlap occurs, the individual waves are going to continue to travel in their original form. So they'll overlap, and once they've overlapped, they're just going to continue, the original waves will continue to travel in their original form. There's two different types of interferences that can occur with waves. It can either be constructive or it can be destructive. Now, constructive interference is going to occur when you've got two smaller waves that combine and build or construct a much larger wave. Okay? Destructive interference is kind of like you're destructing something, occurs when the crest of one wave overlaps the trough of another wave, but the new wave is smaller and less energetic. And sometimes if the waves have equal amplitudes, they can completely cancel each other out and just kind of be flat. Here are some pictures of constructive and destructive interference. You can see here with constructive, you've got two smaller waves that are added together, and the resultant wave is a much larger wave with a much larger amplitude. Destructive interference, on the other hand, you've got two smaller waves coming together, but since the crest of one wave interferes with the trough of another, they end up canceling each other out or being smaller. In this case, since these waves have equal amplitudes, they're just going to completely cancel each other out. Some technology that has been produced or created using this phenomena is what we call noise canceling earphones, which is something that pilots could use if they want to cancel out the noise from engines of the airplane, but you still want to be able to hear maybe a human's voice. So that's kind of a technology that has been created based off of this whole idea that waves can interfere with each other and can kind of either cancel each other out for destructive interference, or they can come together and make a much larger wave, which would be constructive interference. That brings us to the end of our lesson on wave behavior. Please make sure that you have completely filled out your graphic organizer and that you have all of the information that you need on this topic.